We have a series and we want to find out if it converges or diverges. We do the integral test for this one because it's monotonic decreasing and because it has no negative terms. No matter what we plug in, we're going from 2 to infinity, so we do this integral test. Our integral this time starts at 2 and goes to infinity. We can't do infinities here with integrals, so we replace that with a t and say that the limit from t goes to infinity. So with this one, we probably want to do like a very strategic u substitution, or you could probably just do it in your head at this point, but let me show you what it is. It's u equals the natural log of x, because if you remember, the derivative of this is 1 over x. So that just works out perfectly with this. We have x's in here now, because I wrote in x's, you could do n's, whatever. We're just taking the integral. If this converges, that series is going to converge. If this diverges, that's going to diverge. So that's why we do this integral test, because it satisfies two conditions. It's monotonic decreasing, and it has no negative terms. So now we can do this u substitution. We had 1 over u, and this is obviously going to cancel out with this one, because we have x du equals dx. And we had dx in here, so we make that substitution. That would be x du, and we had the x down here from that n, so these two x's cancel out, and we're just left with this, which is obviously the natural log. So the natural log of the absolute value of u, make the substitution back. So we have the natural log of the natural log of x. This is evaluated from 2 to t. We subtract the bottom bound from the top bound, so we have natural log of the absolute value of the natural log of t minus the natural log of the absolute value of the natural log of 2. Over here, we're taking the limit as t approaches infinity. We're really taking it of the entire thing, but it doesn't matter if we apply it over there because it's a constant anyway, we know that. So we plug in infinity into here. The natural log of infinity is infinity, so we have the natural log of infinity. Again, it's inception, and it's still infinity. The natural log of infinity, no matter how many times, it's just going to be infinity. So that's infinity. You subtract some number from infinity, it's still infinity, so this diverges. This diverges.